Hello, today we're going to discuss an important technique of integration in 6.2, integration by substitution. Previously in 6.1, we discussed some basic rules for integration. They're all based on the differentiation rules. We know there is a chain rule in differentiation. Correspondingly, the rule for integration is called the integration by substitution. That will deal with integrals involving composite functions. And so here are the steps for integration by substitution. Step 1, let u equal to g of x, where g of x is part of the integrand, usually the inside function of a composite function f of gx. So we just let u equal to the inside function g of x, or define a new variable u. Step 2, find the du equals g prime and times dx. So this is the differential. Step 3, use the substitution u equal to g of x and du equal to g prime dx to convert the entire integral into one involving only u. So we need to change the original integral to a new one with u. Step 4, find the result of the integral with the new integral. Step 5, replace u by gx to obtain the final solution as a function of x. So let's do some simple examples. We need to find the integral of 2x times a squared plus 3 to the fourth. So in this integrand, we have a composite function x squared plus 3 to the fourth that we can recognize the inside function here is x squared plus 3. So we let u equal to g of x equal to x squared plus 3 as the first step. And then step 2, take the differential of u, we get du equal to g prime dx, which is 2x dx. Step 3, we can rewrite the original integral as x squared plus 3 to the fourth times 2x dx by regrouping. And then we can replace everything in the integral with the new variable u. Since x squared plus 3 is u, so we got u to the fourth, and the 2x dx is just du. So step 4, we can easily integrate this u to the fourth du to get 1 over 5 u to the 5 plus c by the power rule. Step 5, just replace u by x squared plus 3 as we defined in step 1. So we get the 1 over 5 x squared plus 3 to the 5 plus c. So that's the final answer. Let's do another example. Find the integral of natural log x squared over 2x. In this integrand, we got the composite function ln x squared. And the inside function here is just ln x. So we can define u equal to g of x, which is ln x, as step 1. In step 2, do the differential of u, we get du equals g prime dx, which is 1 over x dx. Step 3, we can replace the original integral by using the new variable u. So we can take out 1/2 to get the integral of natural log x squared times 1 over x dx if we regroup it. And that can be written as 1/2 times the integral of u squared times du, since ln x is just u and 1 over x dx is du. And then we just integrate this new integral to get 1/2 times 1/3 u cubed plus c by using the power rule in step 4. And that's just 1 over 6 x u to the cube plus c. In step 5, we just rewrite the result in terms of x. We got the 1 over 6 ln x to the cube plus c. Let's do an application problem in economics. The rate of change of the unit price P in dollars of Apex women's boots is given by P prime equals negative 250x over 16 plus x squared to the 3/2, where x is the quantity demanded daily in units of 100, when the demand function for this boots if the quantity demanded daily is 300 pairs, or x equal to 3, when the unit price is $50 per pair. So this is differential equation, and the initial condition is given. So this is the initial value problem. So we need to find the demand function P from P prime. So what we need to do, just integrate this function of P prime. And you recognize this function P prime is actually including a composite function in the denominator. And the inside function is just 16 plus x squared. So in step 1, we just let u equal to g of x equal to 16 plus x squared. In step 2, take the differential of u, we get du equals to g prime dx, which is 2x dx. Then we just integrate the p prime to get p, so that will be negative 125 times the integral of 1 over 16 plus x squared to 3 halves times 2x dx. If we decompose 250 or factor 250 by 125 and 2, and then regroup the terms inside the integrand, taking out the 125 from the inside and negative sign. And then we can rewrite the whole integral as negative 125 times the integral of 1 over u to 3 halves du, since 16 plus x squared is just u, and 2x dx du. Or negative 125 times the integral of u to the negative 3 halves du. So in step 4, we just integrate it to get the negative 125 times 1 over negative 3 halves plus 1 times u to the negative 3 halves plus 1 plus c using the power rule. So that becomes negative 125 u to the negative 1 half over negative 1 half plus c, which is 250 over u to the half plus c. So replace 16 plus x squared. In step 5, we get p equals 250 over 16 plus x squared to the half plus c. We still need to fix the constant c from the initial condition. So it's given that when x equals 3, p equal to 50. So plug in 50 for p and x equal to 3 into the result in step 5. We got 50 equals 250 over 16 plus 3 squared to the half plus c. So in the denominator, we got 16 plus 3 squared, which is 25. So we got 50 equals 250 over 25 to the half plus c. And the 25 to the half is just 5. So at the end, we got the c equal to 0. So px is just 250 over 16 plus x squared to the half. That's the end for today.